In this tutorial, we explore satellite remote sensing for archaeology. This begins with a brief introduction to multispectral imagery, including the common types that are freely available. Then we install the semi-automatic classification plugin to help download data. This is a powerful plugin that we will only scratch the surface of in regards to its functionality. This is followed by a discussion of common band combinations used by archaeologists and other remote sensing professionals. Finally, calculating NDVI and the importance of comparing various data round out the lesson. As always, timestamps are available in the description so you can jump from section to section. Okay, let's get started. For the most part, when archaeologists discuss satellite remote sensing, we are referring to imagery collected by multispectral satellites. These satellites contain remote sensing equipment that captures image data within specific wavelengths, which range across the electromagnetic spectrum. We access this data as separate files, each matching a different range within that spectrum. Archaeologists tend to use blue, green, red, and near-infrared bands, which is accomplished by combining these bands in different ways. Of course, other bands can be used for different analyses as well. There are many different multispectral satellite systems orbiting the Earth. These include the various Landsat missions managed by the US government, which have been recording data since the 1970s. The European Space Agency manages Sentinel missions, which have been running since the 2010s. Other examples include the Aster and MODIS systems. Also, of course, satellite imagery by services like QuickBird and Iconus exist, but these, of course, focus on visible wavelengths. Think of something like Google Satellite Services. This tutorial focuses on Sentinel-2 imagery. I'll discuss how to use different bands from this satellite, and do note that bands of different satellites do not necessarily record the same wavelengths. In other words, the bands we use from Sentinel-2 may be different for Landsat 8 or Landsat 7, and so forth. So paying attention to the wavelengths associated with each band in this tutorial will allow you to complete similar analyses using data from other satellites. Refer to the description for links about comparing bands between these different satellites as you move through this tutorial, but also if you go out, download other data, and want to do the same types of analysis. We're going to use a plugin to download and work with data in QGIS. Of course, you can download satellite imagery from various websites, and I've included links to some of the most common ones in the description. Now, the plugin we'll be using for this is the Semi-Automatic Classification plugin. Of course, first we need to install it. So come to the Manage and Install Plugins and search for Semi-Automatic Classification plugin. Install the plugin, and once it's installed, you'll notice some new panels and toolbars have been added. You can close the panel. I won't be using it. We won't be using it. Leave the toolbar because that's actually a useful way to access this plugin quickly. Now be aware that this panel we just closed will reopen itself oftentimes. So that's kind of up to you if you want to keep it open or close. I will often just close it to make more space in my layers panel. Now we have to change a couple settings in the SCP before we can use it. And the first one deals with downloading our products. So come to the Login Data tab and make sure you've created credentials or accounts at each of these three websites. Copy the user and password data into these fields. And then finally, for the Sentinel data, note that there may be a different address for the Sentinel data portal, and I've included a link to this new address in the description below. Finally, go into the Settings tab and check the temporary directory settings. I'm going to reset this to what would normally be automatically loaded here, and you can see that there's a space in my directory structure. So I need to go ahead and change this to something that doesn't have a space. If you have a space in that directory or folder structure, this plugin likely won't work. So I just create a new folder specifically for this plugin and select that in one of my main drives. Okay, with that all set up, we're now ready to download Sentinel-2 imagery using the SCP. So now we'll go ahead and download some Sentinel-2 imagery with the SCP. I've already added a base map to QGIS and navigated to an area that I want to download data for. So in the SCP, we'll use the Download Products and Search tab to set up this area. So I'll just drag this a little out of the way and use this button that's Set Area in the Map. And the way we do this is we click with the right hand mouse button first, and then we set the other corner with the left mouse button. And so now when we go back into the SCP, or the plugin window, we can set the product, Sentinel-2. You can see all sorts of other ones are available here. And again, remember, you have to have all of these correctly set up for data to download. You can then also select a date, and I'm going to change this to be a little more recent. I'm going to set the results to 40 just to give myself a few more results, and then click the Find button. This may take a few minutes. This is accessing the Sentinel download website. I'll go ahead and pause the video and resume once it's finished searching. Okay, and we're back. Now, for me, that took about 2 or 3 minutes to download. One of the main attributes that we really want to look at here is cloud cover. And as you can imagine, the cloud cover, this is basically a percentage of how much of the area has cloud cover. So we want something with a low amount of cloud cover. Also pay attention to the acquisition date, because these can be different times throughout the year. And of course, since one of the things that we're examining with multispectral satellite data is vegetation, and then of course you can also change the amount of cloud cover. So if I don't want anything above, say, 10% cloud cover, it would remove everything above that, and I would get results going back further in time. I like the idea of something with almost no cloud cover, so let's click on this. And then we can see this previewed here. So if we click on the display preview of highlighted images in map, this will actually download a very low resolution but small file version of what we're looking at. So let's go ahead and download this one. And we want to go ahead and pay attention to some of these buttons down here. I'm going to unclick the load bands in QGIS. All that would do is once we start downloading these bands, it would automatically add them all to QGIS. I don't need them all added, so I'm not going to do that. I'm also going to unclick pre-process images. We don't want to do any sort of pre-processing to these images, although the SCP has some very robust pre-processing tools included. So we're going to turn off pre-process images. We can leave only if preview in layers, because this is previewing in layers. If we uncheck this and don't have, or even do have something selected, it's going to start downloading all of these. So go ahead and only if preview is in layers, make sure it is in the layers panel. This is click, then we can hit run. And this is going to ask us to save this somewhere. So I'm going to go ahead and create a folder within that larger temporary directory and select that as my download point. We can see the status download up here. We can see it downloading various information, and if we open that folder on our hard drive, we'll eventually see it populating with these different files. Sentinel-2 data is pretty big, so this is going to take a while to download. Okay, these have now finished downloading. Now we can look at these. These are JP2 files, and as we hover or click on each one, we'll see that they're different sizes. And we'll talk about these different bands. You can see this labeled band 1, band 2, and so forth. You're going to see major differences in the file sizes between some. Some will be similar. Band 2, band 3, band 4 are all going to be fairly large. But if we go down to band 5, for instance, we'll see a significant drop. It's about a third of the size. And so what we're seeing here actually is, of course, larger amounts of data, and that's because each of these bands have different spatial resolution. Bands 2, 3, and 4 have a spatial resolution of about 10 meters per pixel, meaning we have pretty good coverage here, much better than, say, Landsat 8 or other multispectral satellites. Now if we go back to QGIS, we can actually exit out of our SCP. Let's remove this preview layer and navigate to what we've just downloaded. And we'll see here a number of different files have been added. We're of course interested in the actual image file, not the layer information file that QGIS reads. Let's go ahead and click on band 2 and bring it in. It won't make a lot of sense now, but as we start to combine these different bands in the next section of the tutorial, we're going to start to create some really stunning imagery that we can use for various forms of archaeological analysis. Okay, now we're going to explore 3 common Sentinel-2 band combinations. The equivalents of these and other band combinations for Landsat 8 are provided in the description. So if you're working with that data set, you can just scroll down and see what these values or these bands would be for that data set. Now we're going to go ahead and add bands 2, 3, 4, 8, and 12 to QGIS. Okay, so these have all been added. I'm going to go ahead and collapse these and quickly rename them. So I'm just going to highlight them, press F2, and that lets me type in a new name. So I'm just going to name that band 12, use the down arrow key, F2, band 8, and just quickly do this for all of these different bands. And this is just going to make it easier for me to read this as I'm using various tools. Okay, so the first band combination we're going to explore is the natural color band. So let's go ahead and turn all of these off. And we can just see our Google Roads layer down here. If we turn that off in the Google Satellite, we can see we're going to actually end up with an image that looks similar to this. And the way we do this is we go into our processing toolbar and search for Build Virtual Raster. And so for natural color, we're going to use bands 4, 3, and 2. Now take note that this of course puts everything in basically alphabetical order. The actual band combination we would need for natural color would be 4 on top, 3 in the middle, and 2 on the bottom. So keep that in mind. It'll become more clear in a moment when we're symbolizing this. But for now, go ahead and click OK. We're not too worried about any of these settings except for resolution. We want the highest. I'm going to go ahead and let it just save to a virtual temporary file. Click Run. Close this, and as we can see, this has created an image, but the colors seem a little off. And that's because the bands aren't properly lined up. The red band should be band 3, the green band is band 2, and the blue band should be band 1. Now, keep in mind that band 1, 2, and 3 do not actually obviously correspond to these bands. It's given them basically virtual or false band numbers. So we have to keep this in our mind when we're using that Build Virtual Raster tool. In this case, band 1 was actually band 2, band 3 is band 2, band 4 is band 3. I know that sounds a little confusing, but you can make a note and just keep that. Once you've worked with this a couple times, it's going to be easy to sort of make sense of. And we can see now that this looks much more like a natural color image. In fact, if we turn on Google Satellite and scroll down, we can see where they meet. You can continue working with the layer styling for this. I often find that reducing the brightness can make this look a little bit more natural. But of course, keep in mind that any differences between these two images is partly because we're looking at data, in this case, that was updated just a few days ago. And so any differences here have to do with, likely with that. So we're seeing here maybe the results of rainfall or lack of rainfall. We don't really know what time of year the Google Satellite image is from. We do know what time of year our Sentinel-2 data is from. Okay, let's go ahead and turn this off and do our next band combination, which is a color infrared combination. And in color infrared band combinations, vegetation really pops out in red. Heavier vegetation being more vibrant. It's easier to tell different types of vegetation apart in this color infrared band combination than in the natural color image. So this is very commonly used band combination in remote sensing when looking at things like vegetation, crops, and wetlands. And of course, as archaeologists, vegetation, crops, and how archaeological features may affect those is really important. Let's go ahead and turn off Google Satellite, just turn on the Google Road again. Of course, to create a new band combination, we're going to build a new virtual raster. And in this case, we're going to use bands 8, 4, and 3. So click OK, again highest. I'm going to leave this as a temporary file and click Run. Okay, let's go ahead and quickly rename these. I'm going to call this one Color Infrared. And I'll rename the one below it to Natural Color. Of course, again, we have to make sure that these bands are properly lined up. So band 1 should be band 3, band 2, and then band 1. And so, unsurprisingly, we're not seeing a lot of vegetation out here, but we are seeing some red along the riverbanks, which makes sense. That's where we're likely going to have most of our vegetation out here. Okay, finally, we're going to go ahead and use one of my favorite band combinations just because it looks really neat, particularly if you're working in an area that does have a lot of vegetation. And this is the natural with atmospheric removal. And here we're going to see that vegetation shows up in more vibrant shades of green. So let's go ahead and turn this one off and create that band combination. We're going to build another virtual raster, and in this case we're going to use bands 12, 8, and 3. Click OK, highest again, and run. Click close. Let's rename this to, I just usually call this natural with Atmo removed. Again, we're going to have to make sure that the bands are set up properly. So we're just going to basically flip the first and third. And here we're going to see, I might darken this a bit, maybe even more. And we can see here, again, vegetation popping up in green. So if we turned on the natural with atmospheric removed and the color infrared and clicked between them, we can see the red and the green lining up. And so we're seeing vegetation again. Now we're already starting to see some features on the landscape pop out. If we turn this off and we turn on our Google satellite, we can zoom in and see that this is actually an archaeological feature here. And so it's already showing up in some of these Sentinel-2 band combinations. Our final form of remote sensing analysis with Sentinel-2 imagery is NDVI. This stands for the Normalized Difference Vegetation Index. NDVI is a simple graphical indicator used to analyze whether or not the target being observed contains live green vegetation. More vegetation or greater vegetation vigor may be associated with better general plant health or with buried archaeological features that affect vegetation health atop it. Of course, keep in mind that vegetation values fluctuate depending on the time of the year. It's one of the great things about these data sets is you can download them at different times of the year, stretching back years, and in the case of some Landsat data, even decades. So calculating NDVI is very straightforward and involves a simple equation. It uses the near-infrared and red bands. So this equation is basically the red band is subtracted from the near-infrared band, and this is divided by the near-infrared band plus the red band. For Sentinel-2, this requires band 8 and band 4, which we've already loaded here. So of course, to do this, we're going to use the raster calculator. Open up that window, and of course we're working with these bands down here. So what we want to start with is we want to begin our equation, band 8, or our near infrared, minus band 4, or our red band. Close that, divide, and start a new area, band 8 plus band 4, close this. We do have to specify an output layer here, so let's go ahead and maybe head to that directory we've been working in so far and just name this NDVI. Click OK. That'll process for a few moments, and then we'll have our NDVI raster. So the resulting raster will have values between -1 and 1. The closer the value is to 1, the higher the overall vegetation value. While the closer the value is to 0, the closer the landscape will be to barren. Values between 0.2 and 0.5 are associated with scrubs, shrubs, and/or grasslands. Values between 0.6 and 0.9 are associated with denser vegetation. We now have our NDVI label loaded. Archaeological features, of course, affect vegetation in a variety of ways. In some cases, completely different vegetation types may grow atop archaeological sites, while in other cases, the general vegetation signatures will be stronger. Buried walls or decomposing organic matter may retain higher amounts of moisture and increase vegetation density in these areas. Now, QGIS comes with some nice symbology preloaded or available for NDVI. We change to single band pseudo color, and we're going to choose create new color ramp, go to opt city or sipt city, OK, and then we're going to select the QGIS set of values, scroll to the bottom, and here we have an NDVI. So go ahead and click that. I often change the number of classes here. That's probably just a personal preference. Reclassify this. Of course, you can tweak the symbology as needed. I will often force these values back to -1 and 1, and that will oftentimes actually produce a much more clearer NDVI data set. And so here we can see a lot of dry and barren areas but also some vegetation. Again, that's of course corresponding to waterways, creeks, and so forth. Of course, we've only scratched the surface in regards to the types of archaeological analyses that are possible with satellite remote sensing data. For instance, you could create 2 different NDVI datasets, perhaps from different seasons of the same year, and use the raster calculator to calculate the difference. For instance, subtract one from the other, experiment which one to choose, and symbolize them as reds, where the deeper the red, the greater the difference. Also, combine these different band combinations with your NDVI. Lower the opacity to help bring out features between them. You could even do this by just simply having your NDVI on top of an aerial image and lowering the opacity to help visualize or draw out features on the landscape. Here in this area, we can already see several of the archaeological features become highlighted when we combine techniques like this. So as you explore various types of analyses that are possible with satellite data, let me know in the comments if you run across something that you'd like to see a specific tutorial on. For instance, read in a journal or a book about a type of satellite remote sensing, and perhaps the analysis is difficult to learn with the tools we've already explored here. I'll go ahead and keep making some other tutorials about this, for instance exploring all of these other types of functions in the SCP that would be useful for archaeology in upcoming videos. So as always, links to location of data are in the description. Make sure to hit that like button and subscribe to get future updates. Until next time, keep mapping the past.